Second section, Unit 3, is titled Prime Factorization. So the standard is 7.ns.1, so find prime factorization of whole numbers and write the results using exponents. So by the end of this lesson, you should be able to find the prime factorization of whole numbers and write prime factorization using exponents. Two vocabulary terms. First is a prime number. A prime number is a whole number that has exactly two unique factors, one and itself. And oftentimes you'll hear someone say that you can't multiply anything else, or you can't divide anything into it evenly besides one in itself. A composite number then is the opposite of that. It's a whole number that has more than two factors. So every number has the factors of one in itself, and only prime numbers, that's it. But for composite numbers, then you'll have several other pairs of factors. So first we're just going to determine whether a number is prime or composite. So please write these examples down in your notes. So if we look at the number 15, you're trying to come up with two numbers you can multiply together to get 15 besides 1 and 15. And if you can come up with something else, then the number is composite. So 15 we can do 3 times 5. So this is composite. 23. Obviously 1 times 23, and 23 does not have any other factors, so 23 is a prime number. 37, 1 times 37, and that's the only other factors of 37, so it's also prime. 22, again 1 times 22, but also 2 times 11, so this number is composite. And actually every even number is composite because you can always divide an even number by 2. Two more vocabulary terms. Prime factorization. This is when a composite number is expressed as the product of prime factors, and we use a factor tree to find the prime factorization of a number. So what we will do when we make a factor tree, and please write these steps down, you write the number that you're factoring at the top, and then you choose any pair of whole number factors for that number. So you don't always have to start at the same place, but in the end, everyone should end up with the same answer if you've done it correctly. When you work on a factor tree, you continue to factor any number that's not prime. So once you get to a prime number on a factor tree, you can stop. And then, actually, I should have a fourth step. We write our answer as a string of the prime factors, and they are in numerical order. And we will use exponents for repeats. So make sure you do have those steps down. So the first example is 90. So what you're going to do is start with 90. We're going to split it up into its factors. I'm going to choose 9 and 10. You don't have to start with 9 times 10. You could start with 45 times 2. It's your choice. 9 is not prime, so I need to keep splitting it down. So 9 is 3 times 3. 10 is also not prime, so I'm going to split it down into 2 and 5. And now 3, 2, and 5 are all prime numbers, so the factor tree is finished, but you have to write your answer as a string of those prime factors in numerical order. So we have 2 times 3 times 3 times 5, and finally when you have multiple of factors of the same number, I'm going to use exponents. So this becomes 2 times 3 squared, since there are 2 of them, times 5. And you can check in your calculator if that's correct. If you do 2 times 3 times 3 times 5, you should get 90. Next we have 24, so I'm going to start with 3 and 8. Again, you could have started with 6 and 4, 2 and 12. You should get the same answer as long as you do it correctly. 3 is prime, but 8 is not. 8 breaks down into 2 and 4. 2 is prime, but 4 is not. 4 splits into 2 times 2. So our string of factors in numerical order, then don't forget about all the ends of the branches. 2 times 2 times 2 times 3. And again, we want to write the 2's using exponents, so that's 2 to the 3rd power times 3. Again, you could check your answer in a calculator. 2 times 2 times 2 times 3 should be 24. Two more vocabulary terms. A monomial. A monomial is a number, a variable, or a product of numbers and variables. So a monomial does not contain any addition or subtraction signs. We're going to practice factoring some monomials where we're splitting up the variables and we're doing a factor tree on any coefficient that might be out in front. So first we factor the monomial. First we're going to start with the 11. So 11, if we do a factor tree, actually is a prime number, so it doesn't factor, but the r factors. There are 4 of them, r times r times r times r, and then the s. So when we factor a monomial, we do 11 times r times r times r times r times s. So you're stringing everything out, including the coefficient, if it's not prime. So 11 is prime, so I can't do a factor tree on it. Number 8, we have negative 28. So I'm going to do my factor tree over here, 4 and 7, and 4 splits into 2 and 2. Now here we aren't going to group our common factors with an exponent. We also have to remember that it's negative. So we're going to put the negative out in front. 2 times 2 times 7. So 2 times 2 times 7. And then we had a squared, so a times a, and b cubed. B times b times b. So there's the monomial factored out completely. So again, the coefficient, the 28, is written as a string of its factors, and the variables are also strung out. I'm also going to put a secret word in today. So today's secret word is purple. Please write this in your notes next to example 9. So we have 18. A factor tree on 18 would be 2 and 9. 2 is prime, 9 is not. 3 times 3. So it's 2 times 3 times 3 times m, and then times n times n times n times n. In class, we will work on worksheet 3.2.